And I talked about how to create a database. You just come to databases on your server under phpMyAdmin and write in the database name here, then you say create. This will create a database like this. Then you can assign your database to a certain user. By default, the user in your database is called root, whose host name is 127.0.0.1. This is the same as localhost. Root by default has no password. So you can assign to it a password. Uh, you can assign to it a password by saying change password. And then you enter in a password here. For example, I called mine root. I know it's extremely weak, but it's okay. And then I say to go. This will assign to it a password. Then I was saying that to understand databases extremely very well, we need to get back to this drawing board before we start writing any database code. Let me first rub all this. So databases are of so many kinds. Of course, for us, we are going to be writing our database in MySQL. But for databases, you need to know that we have three ways of writing databases. The first way is just writing your databases by saying, create this table. A table is a sort of related data. Sometimes we call it a record with fields, also known as columns, that define the different things that make up this database. For example, you can have the users table in your database, and the users table you have, each user has an ID. They have a first name, they have maybe a middle name, they have a last name, they have when they were created in our database, when they were last updated, their password, etc. All these things are under users. Now, someone can just keep on creating these tables randomly like that. In databases, we call that first level normalization format, where all columns are atomic. What does atomic mean? It means that no multi-valued attributes or repeating groups. Like there is no single time you're going to reuse the word first name in some other table. So it's users and that's all again. In case you have another table, let's say admins, you want to know who are the admins, you'll have to rewrite their first names from scratch, and then you rewrite maybe their password again without referring to the users table. Now this is the most amateur level of writing your database. The second one is called the second normal form, 2NF, where every non-attribute is fully dependent entirely on the primary key. For example, if you have the admin and you'd like to refer to a certain user in the users table to be an administrator, you refer by their primary key, the ID, and you call this ID in this admins table that ID 42 is an admin. And this database will understand that every time you change anything about user 42, you've changed a record of this admin. You cannot delete this user unless you first delete them as administrators, because this will leave a loophole in the admins table. But the most professional way of writing a database is called third normal form, 3NF. This is whereby there is no transitive dependencies. Every non-key attribute depends only on the primary key and not any other attribute. You cannot go to any other database and you say, I'm referring to the middle name or anything. So that in case you change anything here, it doesn't affect any record here, as long as this record exists in the users table. So what we shall be doing throughout this entire database building is we shall use what we call primary keys. I want you to do research about this. Primary keys we shall be using primary keys. Primary keys are unique identifiers of a specific record in a certain table. If you have a table called users table, if you have this table called users, and a certain record has an ID called 20, it means that no matter what you change in this record, you can never change its primary key. It will always be unique about this record. For example, if there's a user called Barak, Barak has an ID 20 in the users table. Last name of Barak is Jakisa. Barak is 40 years old. Barak is a software developer. So at one single point, Barak switches from being a developer into being a carpenter. This will not change the fact that if they are calling Barak in the admins table and you've only referred to Barak by the ID, Barak will always remain the same. Even if you change the name Barak here, it won't change. It will not mean that you've crashed anything in the admins table. The name will change in the admins table to the new name you've given to Barak, maybe probably Nassim, as long as this ID exists. If you want to delete this user, you must first delete them from the admins table. So what will the admins table use to refer to Barak? It will use what we call a foreign key. Primary key is locally to users. Foreign key refers to a primary key of another table. Let's get that into coding. We're going to create, I'm doing chakala, I'm doing this and that here and there, but let us first try to build something that is very simple, probably for a school. Let us first get off sports code for a minute and we build something for a school. Assuming we had a school and this school has probably departments, instructors, etc., and we would like to create their database. You need to know the relationship between these different databases. In fact, one of the things that you need to pay attention to is what we call a mermaid diagram. A mermaid diagram. Let me give you an example of a mermaid diagram. Now, this is where I told you that in this generation of developing that you're going to get into, if there is a way you can use AI to speed up your coding, please do. There's this AI called Cloudy. It's so good in front-end development as well as visualization. So in software architecture, the first thing you do before you do any database is to the first thing you do before doing anything, any database, is to plan. We call it software architecture. So let me first show you something here. If we told this AI to generate mermaid code for a school, a university, a university management system with to generate a mermaid code for university with the following tables of a database with all relationships. And then I say the first table that I would like to create is called departments. And I want departments to have, each department has a department ID. Now, this is why you should really know how to do these things from first principles. I know very well that when you're writing database names, there are no spaces. You either write in caps and small letters or you use an underscore. So here we shall have department ID, we shall have a department name, we shall have a location, but we know very well that this is a primary key. It's the unique identifier of department. So this department must have a location. And that's all from the departments table. basically. The second table that we might want is each department must have it must have instructors. So we might need the instructors table. So we might need instructors, and you see each instructor, many instructor each instructor can have multiple departments, and multiple departments might have uh, multiple instructors, but each department has one instructor head. So we have different types of relationships in databases. We have a relationship, you'll see this way from the diagram it's going to generate. We have a relationship that we call one to many. One to many means that one record from one table can refer to many in the other table. For example, when we have users and we have admins, only one user can be one admin. So that relationship is called one-to-one relationship. A one-to-many is one student can do many courses or subjects, but not many subjects are done. Okay, this one is two-way. It's one to many. Then we have what we call many to many. Many schools can do many subjects, whereas many subjects can belong to uh, many schools. So that's called many to many. These are the main types of relationships we have in databases. There are sometimes whereby only one record from one table can refer to one on the other side. For example, I want to give you an example. One player of football can only and only belong to one team, but one team can have many players belonging to it. That is called a one-to-many relationship. So when you're trying to build relationships in a database, you must know which kind of relationship are we trying to have. So for example, we have instructors, and instructors, we're going to have the instructor ID. We're going to have the instructor ID, which is the primary key in principle. We shall have the first name. We shall have, oopsie, I want to maintain the small letters. We shall have the first name. We shall have the last name. We shall have their email. We shall have the department ID. And the department ID is a foreign key that references to the primary key of departments. So this will determine under which department this instructor belongs to. We shall see how we do this. Then the next table we can have is called courses table. And under courses table, of course, we shall have the course ID, which is the primary key. We shall have just a minute. Okay, that's okay. We shall have the course name. Each course has a name. So we shall have the course name. We shall have credits. You know, when you're at university, you might have credit units that you must earn before you accepted to graduate out of that course. So we shall have sort of credits. We shall have a department ID. A department ID again here is a foreign key to departments. Under which department is this course? So which kind of relationship is this? Many courses can belong to only one department. You cannot have a business course in engineering department. So it's a one-to-many relationship. Maybe another thing that we can do, we can add two more tables. For example, students. We can have students table where each student has an ID. So this is a one-to-one. Only one student can have one ID. It's a one-to-one relationship. So student ID is a primary key, and each student has um, maybe we can also have an enrollment ID. Student IDs sometimes can deplete. So uh, let us make the enrollment ID the primary key. It's the unique identifier of this table. We can have the course ID of the different courses that this student is doing, and this is a foreign key to, can you guess, to the courses table. So another thing we might need is the instructor ID, is the instructors that teach this particular student. So many instructors can teach one student, and one student can be taught by many instructors. So it's a many-to-many relationship. Um, we can have enrollment date. We shall look at data types later today, and then we shall have a grade, the different grades of this student. And then lastly, uh, we can have another table called enrollments. Mm, if enrollments relies on students, then we don't need enrollments ID. So student ID should be the primary key, and there we shouldn't have enrollments here. I'll explain why. You see, SQL executes its code on an from line to line basis. You cannot refer to something you've not yet built. You can't refer to a table that you haven't yet built. That's why in MySQL, SQL executes code line by line. So if you haven't yet had enrollment table, you can't have enrollment ID. So ideally, anyway, let me just do this. Ah, let me first stop this. Let me edit. What I wanted to do was to get this and do that, so that under students we just have um, their first name, last name, and probably email and DOB, date of birth. So that here we have the enrollment table that has the enrollment ID, which is a primary key. We have the student's ID, which references to it's a foreign key um, to students. We have the course ID, which is a foreign key to that. Then instructor ID, which is a foreign key to instructors. And then enrollment date, and then grade, the different grades. Let's say A, B plus, etc. Okay, this is okay. So I want you to see how this thing would help you a lot in understanding how the nature of your database will look like. It will generate what we call a mermaid code. Mhm. And then to visualize for you something of this kind. I don't know if I can open this in a new diagram. Okay. All right. It has given us in HTML format. This is better. Though the coloring is poor, very poor. The coloring is very poor. But anyway, let us go with this on a dark background. Or even this. I don't know whether you're able to see. Let me try to tweak around the mode. Dark. But I'm already in dark mode. I'm already in dark mode, so let me tell it to give it to me in. Let it give me the mermaid code itself, because this is terrible. It keeps giving me the diagram. I need the code. Yeah. So there are platforms. There's this platform called Mermaid Live Editor. It helps us to visualize our databases. Use write code. Let me paste my code here. This one visualizes so many things, even flow chart diagrams, but we are interested in this code. Yeah, perfect. Let me try to expand this for you. So this is our database, and I don't know whether you can see it. These things you're seeing on the side, these things, my brother, this is not decoration. It's trying to talk about relationships that I've been telling you about. You see, when it puts an equal sign, it means one side is equal to another. Whereas when it puts this sort of a tributary, it means one record from the other side can lead to many. So it's a one to many relationship. Whereas on this side, it's an equal sign, maybe many to many or one to one. That's what it means. So what a Mermaid diagram does, it helps you to have a structure of your database and how it would look like, so that you know that from the departments table, we are referring to the departments table fits into two tables. The first table is courses table, and the second table is instructors table. In the courses table, this database would help us to know under which department each course is, and under which department is each instructor. Whereas the students table does not refer a lot to any table, so it's Wanjinya, a minute. Wanjinya, I'm telling you what, listen. Hmm? What's it called? Why? Mm-hmm. Let's start with. This is Samsung. Yes, I'm sure. Very sure. Then I counted it, then I left. Hello. I was still saying that this also shows us that the students table is a master database table, just like departments. These students do not belong to any department, but rely on the things that come about the departments. For example, we've seen that the student's ID feeds into the enrollment, and each and everything gets to feed into enrollment. But this can also be a back relationship that a student enrolls into this, courses have enrollments, a teacher teaches into this, then a department employs instructors and departments offer courses. So to be able to build a database of that kind, there are some key things that you must look at, and these are very case sensitive. The first one is called create. You say create a table, and then you mention the table name. Let's say students. What should we start from? Students. Let's start from the very first one. The very first one was departments. So create, and then you call a table departments. You call that table departments, and then you open a bracket. And this is where you define the different fields of that table. For example, you can say we talked about department ID, and then you get to mention its data type. Just like programming, we have data types in databases that a field should refer to. So this is an integer. We say int, and if it's a primary key, you need to mention that it's a primary key by saying this is a primary key, and then you can also press it to what we call auto increment. What does auto increment mean? Auto increment means that for every new record, this department ID will be auto filled into our database. The next thing is department name, and there is a data type we call varchar, variable character, and then we give it the maximum numbers of characters that will be accepted by this field. So you can define this at 100. You can always give them a value of your choice. So I've given mine 100. By the way, every after is a certain line that you add when you're creating a database, you add a comma before you enter a new one. So here we can define things like saying that this cannot be null. So we say not null. Why? There is no single way a department um, cannot have a name. And then there is also something called unique to define that this should be a unique name for each and every department we have in our database. We also had location, which is also a variable character. So we shall say location, and according to AI, it should be a variable character. That location can also be 100 characters long. It can also not be null. I can say this is also not null, so we can say not null, but it might not really be a unique one. Then after writing that table name, we terminate just like in other programming languages, and then you start a new database name. So that's how we refer to a primary key. How do we refer to a foreign key? I'll give you another example where we refer to a foreign key. We shall create a table, and we're going to call this table instructors. We're going to call this table instructors. And under this table, we shall give each instructor what we call an instructor ID. And this is an integer. It's also a primary key, just like the former. I'll just copy this. It's literally the same thing as departments. Okay. And each instructor has obviously a first name. Let me call mine F name. They have a first name, and the first name is a variable character that is a maximum of 50 characters in length. It cannot be null, so we shall say not null. Oh, case sensitive. Not null. They will have a last name that is literally like the first one, so we can copy this and just paste it right here. We can have instructors can have emails. So email is a variable character as well. It can be maximally 100. So this one is also not null, but it must also be unique in the database. Each instructor must have only one email and should be unique. And then we can have what we call a department ID. Now this is where we say the department ID references to, we said it references to the department's table. So here we shall just say this is an integer. Now, when we are done by saying that it's an integer and it's not null, we shall go on to add a comma instead of ending here. Then we come all the way down and we create what we call a constraint. A constraint is a condition where we say FK foreign key, and this foreign key is called instructor. And then in the instructor table, we are trying to get into the department. So instructor department, and under this constraint, we shall say constraint foreign key instructor department. we shall say that foreign key, is that the spelling of foreign? No. Foreign, foreign. So foreign key, that is called uh, department ID. Foreign key that is called for department ID references is references departments, and under departments there is department ID, such that on delete we must restrict deleting one record that would be on this side. This is what I told you earlier. On delete we are restricting that, and also another thing we are restricting is when someone tries to update, then please cascade the changes to reflect on this side. So that's how we refer to a foreign key. And then you terminate and move to the next line. This is ideally how we refer to a foreign key in our system. In principle, you keep on doing this as you refer to a format table, you add primary keys and so on and so forth. I want you to create for me the tables of SportScope, our our project, so that all the tables that will be in your code are third level normalized. And when you're done with that, you'll come and you can either copy everything here, you come to phpMyAdmin that you kept running, go under SQL, then under SQL, just paste what you've written there, copy everything, here, come to phpMyAdmin, paste it there, and I think there is an error in my code around here. Oh, my spelling of references. Let me first fix that. Here is the word references. The error is gone. So after pasting your code here, you just click go, and this will create your table. It hasn't. No database is selected. The foreign key has failed, but it must have created at least one table. No, it hasn't. So ideally, in principle, what I'm trying to mean is that you get your code there and you paste it in here, and the moment you run, it will create these databases in your system. The second option is to use the import button, where you click on import. Then after clicking on import, you upload the file. In which you have your code. So you have to locate exactly where it is. I think it's on disk C, it's under XAMPP, it's under htdocs, under SportScope, under config, and this is the file. And then you say open. Then when you're done, you click import. It will import the databases and create them in your system. I want you to help me come up with those tables, and you shall let me know and we shall start from there. Thank you very much, Nasim.